you intersect any of the two events, it is always a disjoint. So hence we call it as a mutually exclusive event. The first gold coin which you have taken, that must be from box 1 only. Why? Because the second coin is also gold only in box 1. And when you take the union of all the events, the resultive event will be the sample space, and hence they are called as exhaustive event. Hello everyone, a warm welcome to one and all. This is Yashati ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in this session, we are going to study about Bayes' theorem. So what is this Bayes' theorem and what is its application in terms of probability? So before going to Bayes' theorem, we shall discuss about the partition of the sample space. What is this partition of a sample space? We know any sample space can have its n number of subsets. So now when I say a set of events represent a partition of a sample space if they are mutually exclusive and exhaustive events and have non-zero probability. Suppose I consider E1, E2 until En or the number of events, and all the events are mutually exclusive. That means they are pairwise disjoint. You intersect any of the two events, it is always a disjoint. So hence we call it as a mutually exclusive event. And when you take the union of all the events, the resultive event will be the sample space, and hence they are called as exhaustive event. And the value of the probability of all the event must be greater than 0. That means they are non-zero probability events. Thus, those set of events are called as partitions of a sample space. So this is what the definition says. When I consider E1, E2, En are the events and they are said to be the partition of the sample space only when they are mutually exclusive, that is they are pairwise disjoint, and the union of all the events will give you the sample space, and probability of all event must be greater than 0. The next is the theorem on total probability. What is this theorem of total probability? So, when you have E1, E2, En as a partition of sample space, let me consider one more event as A, which is an event of a sample space. Then, the probability of event A can be written as the sum of the probabilities of partition samples with respect to their conditional probabilities, and it is given by P of A is equal to P of E1, P of A conditional E1, P of E2, P of A conditional E2, P of En, P of A conditional En. And in general, we can express this as a summation of P of E, J, probability of A conditional over J, where J varies from 1 to n. So thus, what is the theorem of total probability says? When we have E1 to En as a partition of a sample space, and suppose these events have non-zero probabilities, and let A be any event associated with the sample space, then the probability of value of A can be written as the sum of all probabilities of the partition of the sample space. And this theorem of total probability helps us to define the Bayes' theorem. So what is this Bayes' theorem? So we have here the formula of Bayes' theorem. So when you take E1, E2, En, which are the partition of sample space, which are mutually exclusive, exhaustive and having non-zero probabilities, then event A with non-zero probabilities, we can write P of an event EI conditional with respect to A, which can be written as probability of EI, probability A conditional EI over summation of P of EJ, P of A over EJ. So this is nothing but P of E1, P of A conditional E1, P of E2, P of A conditional E2, P of En, P of A conditional En in terms of the sum, which can be expressed by taking the values of 1 to n. Now, where we use this Bayes' theorem? So, let me take an example where we can use this Bayes' theorem and how we are going to find the probabilities of certain event. Now, let me consider an example. Let me consider we have equal number of men and women. out of which 5% of men have grey hair and 0.25% of women have grey hair. Now, a person with grey hair is chosen. So, my question is, what is the probability that the person is male? That the person is male. So here I have equal number of men and women, and 5% of men have grey hair, 0.2% women have grey hair. Now a person is chosen who have grey hair. What is the probability that the person who has grey hair is men? Now let us first see here, they have clearly given the probability value of men who is containing grey hair and probability value of women who have grey hairs. What is the probability of choosing men and women? So we have 2%. If I say there are equal number of men and women, when I say 2%, so out of 2% I can choose either men or women. So therefore, probability of choosing men as well as probability of choosing women value will be 1 by 2. So because they are equal in number, so we have 50% of chance of choosing women and 50% chance of choosing men. Next thing is, what is the probability of a grey hair person being men? So that is, they have given it as 5%. So 5% means we can write it as 5 by 100. Next, what is the probability of a grey hair being women? That is 0.25%, which is given there. So 0.25 by 100, which becomes 1 divided by 400. Now my question is, what is the probability that the person who has chosen with grey hair is a male? So that means the probability of a man who is a person containing grey hair. So this is what we need to calculate. So when I use this, here where the Bayes theorem helps us. Now suppose if I want to find the probability of an event E1 over A, then the value will be probability of E1, probability of A conditional E1 divided by, and this will be the total sum of the probability value, that is probability of E1, probability of A conditional E1 plus probability of E2, probability of A conditional E2, and it goes on until n terms. But here I have only 2 terms, one is men and one is women. Now I am calculating this, so therefore the numerator will become probability of men, probability of a men containing grey hair divided by probability of men, probability of G conditional M plus probability of women, probability of G over women. So this is what we'll get. So once you substitute all the values here, so here you will get the value 1 by 2 into 5 by 100 over 1 by 2 into 5 by 100 plus 1 by 2 into 1 by 400. When you solve this, you will get the value as 20 by 21. So this will be the value of the probability of a person who has been chosen with grey hair is a male. So here is the formula where we can find the probability whenever there are more conditions implied, and this theorem was developed by Bayes and his name is kept for this theorem, hence it is called as Bayes theorem. Now let us take few more problems. Bag 1 contains 3 red and 4 black balls, while bag 2 contains 5 red and 6 black balls. One ball is drawn at random from one of the bags and it is found to be red. Find the probability that it was drawn from bag 2. So here probability of choosing bag 1 as well as probability of choosing bag 2. Let me take it as event E1 and event E2. So therefore, probability of choosing a bag E1 as well as probability of choosing bag 2 will be same because we have only 2 bags, out of which we have to choose only 1 bag. So therefore, both are equal to 1 by 2. Now, my next condition is, let me take an event A of choosing red ball. Now, they have given here, I don't know from which bag I am choosing, but I can choose red ball. If I am choosing the red ball from bag 1, that is bag 1 is already chosen, so that I need to choose a red ball. Then there are total 7 balls, out of which 3 are red. So this will be the probability of choosing red from bag 1. Now, what is the probability of choosing red from bag 2? So there are here 11 balls, out of which 5 are red. So therefore, the probability of choosing red ball where already bag 2 is selected is 5 by 11. My question is here, I need to find out the probability of a bag 2 when already I have choose the red ball. So that is probability of choosing bag 2 when I have already choose the red ball. Now this again using Bayes theorem, we can expand it as using Bayes theorem. So P of E2 conditional A can be written as, so write the value of probability of E2, probability of A over E2 whole divided by probability of E1, probability of A conditional E1 plus probability of E2, probability of A conditional E2. So the denominator must be the total probability of an event A. So now we know the values here. So it is 1 by 2 into 5 by 11, and here it is 1 by 2 into 3 by 7 plus 1 by 2 into 5 by 11. So we can cancel half in both numerator and denominator. We'll get the value as 5 by 11 whole divided by, so 3 by 7 plus 5 by 11. So when you solve this, you will get 5 by 11. So 11 3s are 33, 7 5s are 35, 33 plus 35, it becomes 68 divided by 77. We can cancel 11 1s are 11 7s are 5 7s are 35 divided by 68. So this will be the value of the probability of choosing a red ball from bag 2. Next. Box 1 contains 2 gold coins, while another box 2 contains 1 gold and 1 silver coin. A person chooses a box at random and takes out of a coin. If the coin is of gold, what is the probability that the other coin in the box is also gold? So now I have 2 boxes. So this is box 1 and this is box 2. So here I have 2 gold coins. Here I have 1 gold and 1 silver coin. Now I need to take a gold coin from any one of the bags. So what is the probability of choosing any bag? Now I need to choose a gold coin from any one of the box. So what is the probability of choosing box? We have only 2 boxes. So probability of choosing box 1, I will take it as E1, is half because I have only 2 boxes out of which I need to choose 1. Next, probability of choosing box 2 is also same, that is 1 by 2. The next thing is 1 gold coin is taken out of one of the boxes. I don't know from which box they have taken. 1 gold coin is already taken out of the box. Now my question is, what is the probability so that when you take out another coin, that is a gold coin? That means the first gold coin which you have taken, that must be from box 1 only. Why? Because the second coin is also gold only in box 1. That is why I need to choose the probability of choosing bag 1 when you have already taken one gold coin outside the box. They have also given that probability of taking a gold coin from box 1. So first I have already chosen box 1. My next thing is I need to take out a gold coin from box 1. So out of 2 gold coins, I have an option of selecting any one gold coin out of 2 gold coins. Both are 2 gold coins. So therefore their probability is 2 over 2. Hence the value is 1. Next is I have already chosen back 2. I am taking out a gold coin. So out of 2 coins, I have only 1 gold coins. So therefore the value of the probability is 1 by 2. Now here is what I need to show, that the second gold coin must be chosen from bag 1 only. That is why my probability value is even conditional A. Now again using Bayes' theorem, probability of even conditional A can be written as probability of even, probability of A conditional even whole divided by the total probability, that is probability of even, probability of A over E1 plus probability of E2, probability of A over E2. So E1 is 1 by 2 into 1 whole divided by 1 by 2 into 1 plus 1 by 2 into 1 by 2. So you can cancel half in both numerator and denominator. So here you will get it as 3 by 2. So therefore the value is 2 by 3. So therefore the probability of choosing the second gold coin when the first coin is already gold is 2 by 3. Next, a bag contains 4 red and 4 black balls. Another bag contains 2 red and 6 black balls. One of the 2 bags is selected at random and a ball is drawn from the bag which is found to be red. Find the probability that the ball is drawn from the first bag, same as the previous one. So, probability of choosing bag 1 as well as probabilities of choosing bag 2 will be one and the same, 1 by 2. Let me take event A as choosing red. Now, one of the 2 bags is selected and hence their probability is 1 by 2. A ball is drawn from the bag. So, what is the probability of a ball drawn which is red from bag 1? So, there are 8 balls out of which 4 are red, hence the value of the probability is 1 by 2. Next, what is the probability of a red ball which has chosen from bag 2? That is, out of 8 balls, there are only 2 red, hence the value is 1 by 2. Now, my question is, I need to find out the bag is first bag when a ball drawn is a red. So, hence I can extend this as P of E1, P of A conditional E1 and the total P of E1, P of A over E1 plus P of E2, P of A over E2. So, this can be expressed as 1 by 2 into 1 by 2 whole divided by 1 by 2 into 1 by 2 plus 1 by 2 into 1 by 4. So, 1 by 2 in both numerator and denominator I can cancel. So, then the numerator is 1 by 2 and here I have 3 by 4, 2 1s are, 2 2s are. So, therefore, the value is 2 by 3. So, thus the probability of the bag which was chosen was first bag only is 2 by 3. Next. An insurance company insured 2,000 scooter drivers, 4,000 car drivers and 6,000 truck drivers. The probability of accidents are 0.01, 0.03 and 0.15 respectively. One of the insured person met with an accident. What is the probability that he is a scooter driver? So, therefore, here I don't know the probability of scooter drivers, car drivers and truck drivers, but I know the probability of accidents with scooter drivers, car drivers and truck drivers. Now, I need to find out a person met with an accident is a scooter driver only. First, let me take E1 as the event of probability of scooter drivers. In total, 12,000 drivers, out of which 2,000 are scooter drivers. Hence, the probability value is 1 by 6. Next, probability of E2, that is car driver, is 4,000 out of 12,000 drivers. Hence, the value of the probability is 1 by 3. Next, probability of truck drivers is 6,000 by 12,000. Hence, the value is 1 by 2. They have given a person who met with an accident is a scooter driver and its conditional is given as 0.01 and probability of A over E2 is given, that is 0.03 and probability of A over E3 is given, that is 0.15. Now, I need to find out the probability of one of the insured person who met with an accident is a scooter driver. So, this is what I need to find. Now, I have 3 events there. So, therefore, the total probability under the denominator will be the sum of all 3 events. So, here E1 over A can be written as P of E1, P of A conditional E1, P of E1, P of A conditional E1, P of E2, P of A conditional E2, P of E3, P of A conditional E3. So, now let us write the values. So, first one I have 1 by 6 into 0.01 divided by 1 by 6 into 0.01 plus 1 by 3 into 0.03 plus 1 by 2 into 0.15. So, on solving this, I will get the value as 0.01 divided by 0.52 or the value is 1 by 52. So, this will be the value of the probability of a person who meets with an accident is a scooter driver. Next. A man is known to speak truth 4 out of 5 times. He tossed a coin and reports that it is a head. Find the probability that it is actually head. Now, an experiment or random experiment which has taken is here tossing a coin. So, let me take E1 as an event of getting head and E2 of an event not getting head. Not getting head means it has to be a tail. So, what is the probability of E1? It is 1 by 2. What is the probability of E2? It is again 1 by 2. Now, here they says he tosses a coin and reports that it is a head. That it may be truth also or it may be a lie also. But they have given he will say truth 4 out of 5 times. So, that is probably, let me take A as an event. He reports head. He reports head. I know here the probability of head is 1 by 2. Now, what is the probability that he reports head when a coin which we have already tossed is head? That is, they have given it as 4 out of 5 times. Now, what is the probability that he reports head when we have already got tail? It is exactly the complement of this, that is 1 minus 4 by 5, hence it is 1 by 5. Now, I need to find out what is the probability that the man is telling truth, that is reports head when it is actually a head, when it is actually a head. So, that is given by probability of E1, probability of A conditional E1 whole divided by probability of E1, probability of A conditional E1 plus probability of E2, probability of A conditional E2. Let us substitute all the values here. So, we have the values as 1 by 2 into 4 by 5 divided by 1 by 2 into 4 by 5 plus 1 by 2 into 1 by 5. We can cancel 1 by 2 in both numerator and denominator. Then we get 4 by 5 divided by 4 by plus 1 by 5 we'll get the value. So we can cancel 5, 5. So the value is 4 by 5. That is the probability that the man reports head when it is actually head is 4 out of 5 times, or we can say 4 by 5 is the value of the probability. Next, a man is known to speak truth 3 out of 4 times. He throws a dice and reports that it is a 6. Find the probability that is actually 6. So here the random experiment chosen was throwing a dice. So when a die is thrown, he reports it 6, whether it is 6 or whether it is not 6 also. So that means we have 2 events. That is, event E1 is 6 appears. Then what is the probability of getting 6 when a die is thrown? Only 1 chance out of 6 outcomes. Let me take E2 here, that is 6 does not appear. We take this an event as 6 does not appears. 6 does not appears on the face means the dice may show 1, 2, 3, 4, 5. So therefore, what is the probability value? That there are 5 chances where we will not get 6. That is 5 out of 6. Now, let me take A as an event that he reports 6. So, he says 6. It may be true or it may be lie. They have given he reports 6 when it is actually 6 3 out of 4 times. So, that is probability of A over E1 is given. And when you take probability of A over it is E2, it is exactly the complement of this. Hence, it is 1 minus 3 by 5, which becomes 1 by 4. Next, I need to find out the probability that it is actually 6. That the person reports 6 when it is actually 6. Hence, again, extend the formula, that is probability of E1, probability of A over E1 whole divided by the sum of probability P of E1, P of A over E1 plus P of E2, probability of A over E2. Now we know all these values E1, E2, A conditional E1, A conditional E2. So therefore here it is 1 by 6 into 3 by 4 whole divided by 1 by 6 into 3 by 4 plus 5 by 6 into 1 by 4. So we can cancel 1 by 6, 1 by 6. Then we will get 3 by 4. So here 3 by 4 plus 5 by 4 is 8 by 4. 4, 4 get cancelled. Hence the value is 3 divided by 8. So this is the conditional probability of a man speaking a truth when it is actually head. So this is how the Bayes theorem helps us to find the conditional probability of few random experiments. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.